Let's continue talking about stereochemistry. And this time, let's focus on stereoisomers. We said that this is a special type of isomers, and they have, remember we say they have the same as all the isomers, same molecular formula. And they will have same connectivity, but they will have something different, the relationship in the space, a difference, a spatial relationship between groups. And we gave a couple of examples before. And one was, say, this molecule, this actually, that's called trans 2-butene, 1, 2, 3, and 4. And we gave this example. So, but we didn't talk much about that. We just introduced, say, the subject. What are stereoisomers? And we said that here we see, this is the inventory of the atoms. So we say here that we have 4 carbons. So let's do the molecular formula for the 2. So we have a C4, right? And here I have a 6 and 8 hydrogen, right? So that's my inventory. The 2 molecules have the same. Not only that, but I see that if I number the atoms in the 2 molecules, I see that there is a double bond between carbon 2 and 3, and 2 and 3. Connectivity-wise is the same. But I notice also that these 2 metal groups are opposite to the double bond, and here they are to the same side. So different relationship in the space of the 2 metals, let's say, of the 2 groups. So spatial relationship. So now they have a name to differentiate those. The 2 molecules, the name is in general, say, 2-butene. So in carbon 2 starts the double bond. So that's a termination for alkene, and but is a prefix for atoms. So 2-butene, but we know they're different. So I cannot name it the same. I need to add something else, and that something else is what says the relationship of these 2 groups. When they are opposite in the sides of the double bonds, let's say this is called trans. So this is trans 2-butene, and these 2 are to the same side. We're going to call those cis. So this is cis 2-butene. And let's do another example of that. Let's say that I have now this 2. Notice that these are, let's do the name of that. This is a cyclohexane. And here I see that in carbons 1 and 2, 1, 2, I have 2 metal groups. They have the same molecular formula, same number of atoms. Connectivity-wise, I have a metal carbon 1, a metal carbon 2. Same thing here. But I see that one metal is pointing towards me, the other is pointing away. So different side, one up, one down, let's say. And these 2 are pointing to the same side. So the same side, we're going to call that cis. So cis, and because we have 2 metal groups, remember, this is the parent name. We need to say also 1,2-dimethyl cyclohexane. But this is going to have at the beginning of the name this word, cis 1,2-dimethyl cyclohexane. And this is the trans 1,2-dimethyl cyclohexane. Now, when we ensemble the whole name, we're going to put here, say, a dash. I'm going to say trans. This is this one. Trans 2-butene. In the case of cis, you're going to say cis dash and all of that. Same thing here. Now, to distinguish that from, say, constitutional isomers, let's do one more thing here. We said that these two are stereoisomers. Let's investigate the relationship with another molecule. This two, we see that the two metals are pointing up, up, up. So same side. But now they are connected differently. They are in carbon 1, 2, 3. This is 1,3 dimethyl, and then cyclohexane. Notice connectivity is different. So the relationship between this on the top and these two are constitutional isomers. Right? Also, these two are constitutional isomers. And these two, in the bottom, these two here are related as stereoisomers because they have same molecular formula, same connectivity, 1,2 dimethyl, but different relationship in the space of the two groups. We're going to be doing more examples of that and more types of stereoisomers.